Kids, we have only 2 questions in this exercise, so let us finish this in the same class. Okay, just moving it here. Okay, so the first question is, can you recognize the pattern in each of the sequences in table 3? So this is our table 3 and we have to recognize the sequence. Okay, that it can be what sequence? I am writing it here, answer number 1. Okay, and since we have done this, so I'm doing one thing. Okay, let me just copy this figure here and let me do this. Okay, it will be much faster and easier way. And let me also remove this. It will take a bit from here. And let's start this. Okay, so what we have to do is we have to identify which sequence is this. We have to see which sequence it is following. So if you can see here, this starts with 3, then it has 4 sides, 5, 6, 7, 8 and so on. So can we say that this is a counting number sequence which starts with 3 here? Okay, so we can say this is a counting number sequence. This is a counting number sequence starting 3. This starts at 3 from here. 3, 4, 5, 6, 7, 8, 9, 10 and so on. Right? Next is complete graph. So in this case of complete graph also we are following a sequence. Again, this is a sequence, counting number sequence. This is a counting number sequence starting from 2. Okay, for graphs. 2. For stacked square, so this is 1, this is 1 square, this is 1, 2, 3, 4. This is total 4 square. So can I say this is 4? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. And then 16. 1, 2, 3, 4, 5. 25. Right? So can I say this is 1 square? This one is 2 square. This is 3 square, 4 square and 5 square. Right? So this is a sequence of squares. Sequence of squares. And that is 1 square, 2 square, 3 square, 4 square, 5 square and so on. Right? Next, we have stacked triangles. So we have one here, one triangle here. Then we have 1, 2, 3, 4. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay. So here also these triangles, they are following a sequence of squares. Okay. They are also following a sequence of squares, but we are representing them in the form of a triangle. And in the above also, they are following the sequence of squares, but we are representing them in the form of a squares, and so on. Okay, the last one we have Koch snowflake. So kids, what we did here was we had this, okay, we had three sides shape with us, and then we divided it equally into three parts using a triangle here, here, and here. So what we did was we divided this shape into 12 side shape now. So for Koch snowflake, what we have is that to get every another shape, we have to multiply it by 4. So for the first shape, we had 3 sides. The next shape, we had 12 sides. And I'm just writing here, this will be 3 plus 4 and we will get 12. And the next one, we will have 12 multiplied by 4 again. So we will have 48. And next, we will have here 48 multiplied by 4. The number which we will get, that is here 192. Okay. So and so on. So to get every next term, the next term and the next shape, we have to multiply it by 4. So this is what we have in Koch snowflake. Okay. Now coming to the second question. Try and redraw each sequence in your notebook, and can you redraw the next shape? So kids, we have to draw the next figure in the sequence starting with the regular polygons. Okay, so we can see that in this shape sequence of regular polygons, the last shape has 10 sides and 10 vertices, and we are asked to make the next shape. So the next shape will have 11 sides and 11 vertices. So let's start making the next polygon, which will have 11 sides. So kids, the polygon which has 11 sides is called as hendecagon. Okay, hendecagon. And I will tell you how to make it. You all have pencils. So what you all do is make a light circle using your pencil and mark 11 dots at equidistant from each other, which are equidistant from each other at equal distances. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now erase the in-between space. Why we are erasing the in-between space? These curved lines? Because a polygon will have straight lines. It will not have curved lines. But in circle, we use the curved lines. So I am erasing the curved lines between these dots. Now this is done. Now let us join all these points using straight lines. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So here this is hendecagon. It has 11 sides and it has 11 vertices. This is the first shape. I'm writing here it has 11 sides and 11 vertices. Okay. Now, what is the next part of the question? After each why or why not? Okay. Can you draw the next shape? Why or why not? We have done. We have drawn. After each sequence, describe in your own words what is the rule or pattern. This is the next question. But in the first question, we will just have to recognize the pattern. Okay. So that we have done already. And now we are drawing. So the pattern is, it was counting numbers. We have already recognized. It is using counting number pattern, starting from 3. So it is 3, 4, 5, 6, 7, 8, 9, 10, 11 we have drawn, and it will go on increasing. Okay, next one is we have to make the next shape in your complete graphs. So in complete graphs, if we see here, we have made till 6 points graph. It's a 6-point graph. Now the next will be a 7-point graph, right? So let us start creating this. Again, for 7-point polygon, which we'll have to create to make a complete graph, we can make a use of circle like what we did earlier. So I'm using a circle and I'm marking 7 points. 1, 2, 3, 4, 5, 6 and 7. And again, I am erasing the in-between space. Okay. So this, because we have to make the straight lines. Now, I will make straight lines. It will be 1, 2, 3, 4, 5, 6 and 7. So this is our 7-sided 7-point polygon, which we are using to make a complete graph of 7 points, 7 sides. So what we are going to do, we know that here in case of graph, every point should be connected to every other point. So I will start from here. This one is connected, this one is connected. So we have to connect this 1, this 2 and this 3. This is done. Now both of these, they are connected. Starting from here, I have to connect this one to this first, second, third and fourth, right? Now similarly, this I have to add here. This is already connected, this is already connected. This I have to connect, this I have to connect, and straight this I have to connect. So this side is done till this point. Now coming here, so this particular point is connected to the adjacent point. This is connected here and here, also to this point, but not to this point. So I am connecting them like this, right? This is connected, but this is also not connected. So I'm also connecting it like this. Okay. Now coming to this point. This point is connected to this, but not to this. So I'm adding one here. Now these are also connected. Now this point, it is connected here, connected here, connected here, connected here, connected here, connected here. So we are not making any new lines here. Now this point here, it is connected to this point, this point, this point, this point, this point, and this point. So it is connected overall. So this is our complete graph. And again, we saw that in case of complete graph also, it was using the counting number pattern, right? It was using the counting number pattern starting from 2. Okay. So I'm writing that pattern again here. It is 2, 3, 4, 5, 6, and this one we have made 7 and so on. It will go on increasing. I hope this is clear. And next we will go to the stacked square. So kids, in a figure which is given to us in the above table, this table, we have the last stacked square of stacked squares of 25 squared figure. So this particular big square, it has 25 small squares stacked. So next one will be a 36 stacked square figure. Okay, because this was the sequence of squares: 1 square, 2 square, 3 square, 4 square, 5 square. Now we have to make a 6 square figure. So I'm writing here stacked square of 36 stacked square figure. Okay. So how we are going to do this? I'm going to take a big square. Okay. And I'm going to divide it into 6 equal parts. Okay. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And horizontally also we have to divide. So this is 1, sorry, this is 1, 2, 3, 4, 5. So if you count these squares, they are 36 squares. You can also count like this 1, 2, 3, 4, 5, 6. Same on all the sides. So this is a 6 square, or you can say it is 36 stacked square figure. Okay. And the pattern it follows, we have already seen, it will follow a square sequence. Pattern it will follow is a square sequence. It will follow the square sequence, which is 1 square, 2 square, 3 square, 4 square, 5 square. Here we have drawn 6 square, and so on. Okay. Now, next we have a stacked triangle. So here in the figure, the last triangle we have made is again a square of 5. It has 25 triangles. So next we will make a square of 6. That is, the triangle will have 36 stacked triangles. Okay. So we have to make a 6 square, that is 36 stacked triangles. How we have to draw? So what we will do is, we will make a big triangle. Wait. Okay. It should be a equilateral triangle. All the sides should be equal. Now we will draw. This is 1. This I'm going to divide. Okay. So this is 1, 2, 3, 4. Now again I'm going to divide this one. How? It will be like this, and this, and this, and this. 1, 2, 3, 4, 5. So next one we will have 7. Okay. In the next one we will have 7. It will be like this, and this, this, this. 1, 2, 3, 4, 5, 6, 7. The next will have 9. So it will be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11. 9, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll just correct this. Right. And the last one we will have 11. So how we are going to make 11 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we count this, it is a 36 stacked triangle figure. This one. And the pattern we are following is pattern of squares. Okay. It was 1 square, 2 square, 3 square, 4 square, 5 square, and 6 square. So kids, if you observe one thing here, what we have done is, In the very first one, we have one triangle. The next one, we have 3. In the next one, we have 5. In the next one, we have 7. We have 9 and we have 11. So now can you recognize the relation between the sequence? And that is, when we add the odd numbers up, we will get a pattern of square numbers, right? Here we are adding up the odd numbers. These odd numbers we are adding up, and in the output we are getting a pattern of squares. Okay, yeah. Next is the last one, which is a Koch snowflakes. Fifth one, I'm writing here, Koch snowflake. So kids, we saw how we have to draw this. I'm going again to this figure. Okay, so what we did, the first one had 3 sides, and then we made small rectangle and divided it into equal parts each side. And further, in the very next one, again we made triangles here and we further divided, right, it into this one. We did something like this and we got this figure. And here again we have to make these small triangles, and then this will come. So this will go on. So the pattern which this figure is using is that the first figure in the Koch snowflake, it will have 3 sides, and the next, to get the next figure, we are multiplying it by 4. Okay, so we are multiplying this number with 4, the previous number. So I'm multiplying 3 into 4 to get this, now 12 into 4 to get this, and so on. Or we can also say that we are multiplying this with the power of 4. 3 multiplied by 4 raised to the power 0. And for the second number, 3 raised to the power 3 into 4 raised to the power 1. For the third, 3 into 4 raised to the power 2. Next one, 3 into 4 raised to the power 3. This, and for the last one shown here, 3 into 4 raised to the power 4. So the next which we will have to draw, it will be 3 into 4 raised to the power 5. Okay, see, you see here, 4 raised to the power 0 is 1, so that is 3. 4 raised to the power 1 is 4, 4 multiplied by 3 is 3. 4 raised to the power 2 is 16, 16 multiplied by 3 is 48. Okay, and so on. We will get bigger numbers. Okay, so in Koch snowflake, what we have to do is, the first figure will have 3 sides, and the next figure, to get the next figure, we will have to draw triangle on each side and divide it equally, like we have done. So in the last one, I am just writing Koch snowflake. It follows the below pattern. And what is the pattern? 3 times, it follows 3 times power of 4. Okay, that is 3 multiplied by 4 raised to the power 0, 3 multiplied by 4 raised to the power 1, next 3 multiplied by 4 raised to the power 2, next 3 multiplied by 4 raised to the power 3, 3 multiplied by 4 raised to the power 4, 3 multiplied by 4 raised to the power 5, and so on. This is the pattern it is following, and to draw this we will not be able to draw. It's a huge diagram which we cannot draw here. Okay, but we know how to make it, right? So kids, this brings us to the end of this particular exercise and concept 1.5. And in the next class, we are going to study the relation of these pictures of, or you can say of these shape sequences with the number sequences. A part of this we have done today also, but in more detail we are going to study in the next class. Okay, so this brings us to the end of this class, and I will see you all in the next class.